Good day, everyone, and welcome back to Supply Side Network 365 and our webinar today, Zinc Bisglycinate for Immune Health, a superior alternative to traditional zinc, brought to you by Innophos. Innophos brings passion, precision, and forward thinking to creating essential ingredients to improve quality of life. Please be sure to also visit their company page here on Supply Side Network 365, where you can find additional information, and you can also connect directly with company contacts, including our speaker today, Dr. Robert Finn. Before we continue, I'd like to invite you all to stay active in the live discussion. We hope that you interact with each other, and also invite you to pose questions within the discussion. And that chat function, excuse me, is in the lower right of your screen. It says live discussion, and you can click on that pop-up. Or if you're on the app, click live discussion. Clicking there, you'll also note that in that chat box, you'll see a tab that's called polls. And we would really appreciate it if you could just take a moment and please fill out your answers to that poll. There are 3 questions there. It'll just take a moment. So we encourage you to do that. It gives us a little bit more information about where you're at today, so we can help understand what your needs are and respond appropriately or address appropriately within the content today, because this is live content. So on to our subject. Of course, all eyes over the nearly last 20 months have been on immune health and optimizing immune system function. The numbers continue to grow, and there's still a strong market generally for minerals. And with numerous dietary strategies, of course, for providing support for the immune system, zinc has remained a steadfast mineral supplement leader in the category because of its immune support. But of course, not all minerals are necessarily equally effective. And today we're going to talk about why that is and how you can create more efficacious products by really targeting the kind of zinc specifically in your products. Today, Dr. Bob Finn, who is the Director of R&D at Innophos, discusses the characterization of chelated minerals and the importance of bioavailability for absorption, and how, of course, chelation can enhance dissolution of a mineral. Sharing his recent study comparing zinc bisglycinate to zinc oxide, Dr. Finn shows the significant advantages of the chelated zinc bisglycinate form. Dr. Finn has been with Innophos for over 17 years. You're in great hands. He's pretty much authored the academic body supporting this information today. He previously served as a senior scientist and principal scientist before engaging in his present role, for which he's been in for nearly 8 years as Director of Research and Development. Before I do hand it over directly to Dr. Finn, I want to remind everyone again to stay active in that live discussion. As noted before, if you have questions, please pose those there, and I will be able to field those to Dr. Finn later on. And also just remind you again to answer those poll questions if you can. It just takes a moment. Additionally, the slide presentations for today are available via PDF in the documents section related to this session. You can see it right there on your screen. We've also included a link to the Innophos site for access to the white paper on Chelamax zinc bisglycinate, what we'll be talking about, of course, today. So that's available for you, just a quick click and a short form. Please ask your questions. And with that, I'm going to hand it right over to Dr. Finn to get started. Thanks.
Thank you, Francine, and thank you for that introduction. Hello, everyone, and thanks for joining me today. I have been with Innophos for 17 years and 2 years in the phosphates division of Rhodia before that. So it has been a long time in this space, and it's been really enjoyable. About 9 years ago, Innophos entered into the dietary supplement space, adding in mineral supplements. This was particularly exciting for both me and my team, as we got to branch out in terms of the science that we were able to explore and understand. Personally, for me, it was nice because my degree is in inorganic chemistry, and I was able to get back to some of those minerals that weren't originally offered in the Innophos portfolio back in those days as just food phosphates. So thank you for joining me today. I have a compelling story of why chelates are better than inorganic minerals. Our agenda today, we're going to start with marketing data. As Francine did mention, the market is strong for chelates, minerals, and especially here during COVID. I want to talk about what is a chelated mineral, how are they formed, and talk to you about the analytical methods we use to prove out chelation. This is particularly important because there is some confusion in the area. When you look at a supplemental label, sometimes it's not as clear as you would like it to be when talking about mineral supplements. I'm going to transition then into how this chelation affects bioaccessibility, because ultimately we want to get to a point where we can prove bioavailability on these chelated minerals. That's really our goal. We're going to follow up with some tablet data with dissolution properties. I'll finish up with uses and benefits, and then we'll leave it open for some questions and answers. So what I hope you get from today are the key messages. Chelated minerals are actually a superior supplement to an inorganic mineral. Bioaccessibility is key to mineral absorption. If you want to really be able to absorb that element that you're taking in your supplement, it needs to be bioaccessible. That's critical. And finally, chelation can enhance the dissolution of a mineral. And when I'm talking about inorganic minerals at this point, I think it's clear I should make it clear that I'm talking about mineral oxides, carbonates, sulfates, those inorganic simple salts that are traditionally used in supplements. So starting with the marketing data. Demand for mineral supplements continues to grow. The global market right now for human nutrition of just mineral ingredients is about $4 billion. It's been steady growth throughout. Obviously, COVID-19 has not changed that at all. When you look at the top 3 minerals here on the right-hand side, you can see magnesium, calcium, and zinc. So this is particularly important because it tells us why people are, or what people are interested in when they're buying their mineral supplements. You're getting health benefits from these things. As was mentioned, zinc is known to improve immunity. You're also getting health benefits like calcium for bone health. But magnesium is tops on the list, and that provides a number of functions, including enhancing mood, relaxation. We're seeing the same sort of thing on either people looking for ways to benefit their health or ways to benefit their lifestyle, looking for something to help them relax, something to reduce stress. It's a very stressful time during this pandemic. In North America, the new product launches with zinc have been through the roof, really, during the pandemic with a 73% CAGR. It's not that unexpected when you think about its strong ties to immunity, but 73% is pretty high. And in North America, we lead the geographies for mineral supplement launches. So I'd like to begin with what is chelation and build from there. If you start with an inorganic mineral, you can see that on the left-hand side. I've represented zinc oxide here as just a simple blue circle. We can react it with a ligand. In the middle, you can see glycine. And then once the reaction is completed, you have this sort of what I've described or colored here as kind of a protective coating, and that's a chelated mineral. What's really happening here is that the amino acid, the glycine, is bonding to form a chelate with the zinc. You can see glycine in the lower center of the screen. There's the hydroxide group and an amino group. So it has 2 different bonding points on that ligand. Both of those points can react with the zinc and bond. And when both of those do bond, it's considered a chelate because it forms this ring structure. You can see it in the lower right-hand corner. The chelate is known when a ligand actually bonds to a metal in 2 positions. The ring structure is one of the more stable structures you'll find in chemistry. 5-membered and 6-membered rings are especially stable and known throughout organic chemistry. So the stability that comes from the chelated mineral is not so much this, we're protecting the zinc so that nothing can touch it, but it's about the zinc being in this stable form that is just happy It's not looking to react any further, and it is able to move through the digestive tract without occurring any unwanted side reactions. On the other hand, if we were to start with just zinc oxide and take that as a supplement directly, there's a chance for it to actually bind to other elements within the digestive tract, depending on what's been eaten and what is in the digestive tract at that time. You can have other nutrients or anti-nutrients bond to that zinc, and the absorption of that zinc will actually decrease based on those side reactions occurring. So the protective nature of the amino acid as a glycine around the zinc allows that zinc to get through the digestive tract and remain more bioaccessible. However, without having those glycines there, that zinc oxide can react with other items within the digestive tract. We would call it chelated mineral. You'll hear me say organically bound occasionally. They're really synonyms. The two terms mean the same thing. We're using an organic amino acid ligand to bind to the zinc. So why is chelation important? Well, the advantage of chelation is it provides consistent solubility throughout the digestive tract, which is critical for bioaccessibility and mineral absorption. I have a few studies which I'd like to describe now to help emphasize this point. These studies are actually did not take place at Innophos. The reference is at the lower edge of the screen, so you can look at those if you want. This was from aquaculture in 2013. And this was an animal feed study comparing chelated zinc source or organically bound zinc sources to inorganic zinc sources. The study was for the efficacy of trace mineral premixes in Pacific white shrimp. In this case, in livestock especially, over the last several years, the supplementation and the efficacy of supplementation has been a key area, as over and under supplementation within that space can be detrimental to the livestock. So if I can call your attention here to the table on the right-hand side of the screen, the inorganic compounds, the control and the inorganic are in blue, and the chelated is in green. What you can see is that just from a control with no zinc source given in the diet for the shrimp, only a 58% survival rate was found. That's got to be difficult as a shrimp farmer to expect a 40% loss with no supplements. So it's clear why they're looking for supplementation. When adding in zinc sulfate, what I would call an inorganic zinc source, they do get an improvement up to 76% survival rate, which is a nice improvement over the control. However, when that's compared to the three sources of chelated zinc, zinc methionine, zinc glycinate, and zinc glycinate, all of those had survival rates over 90%. So it's a huge improvement on the control and a huge improvement over the zinc sulfate, with zinc methionine being the highest at 95%. Much better result for the farmers who are looking to raise the white shrimp. And down in the lower left, I've taken a blurb from the article. Shrimp-fed diets with organic zinc supplementation produce significantly higher growth, survival, and immune parameters than the zinc sulfate treatment. And the other data for the growth and immune treatment is within that article, but I'm not going to discuss it today. On to the second trial. This was chelated zinc absorbed in a human trial. So in this case, it was 15 young adults in a randomized, double-blind, three-way crossover design. The importance of this study, not only was it a comparison of zinc oxide to citrate and gluconate, but in this case, diets were not controlled. So the young adults were able to consume their normal diets and just come in for their supplements and to check on the zinc absorption. Once again, the inorganic is shown here in the blue column, with the chelated being shown in both the green. Both of the green columns are chelated. You can see both the chelated of citrate and gluconate had a 22% improvement in the overall absorption versus the zinc oxide. The more insoluble zinc oxide is less well absorbed when given as a supplement without food and may be minimally absorbed by some individuals. In this case, in the Journal of Nutrition here, there were some data points they had as outliers within the oxide set, they couldn't explain as to why the oxide levels were so low. And so that's why they talked about them being minimally absorbed by some individuals. That comes back to bioavailability and perhaps some dietary issues that led to a lower level of zinc being able to pass through the system. So now that we've seen some of the efficacy of zinc chelates from the open literature, I want to move on to the issue of transparency in the market. It's a key issue and a key trend that customers are looking for today, and it's important that we cover it. Excuse me. So I took 3 supplement fact labels off of a simple search and wanted to compare them for you today. The product labels you'll see here can be a bit confusing, a bit misleading for consumers. If we look at supplement fact panel A, the source here is magnesium from magnesium glycinate chelate and magnesium oxide. What's occurring there is likely a blend of a chelate and of the simple magnesium oxide. And the most likely reason for that is they're looking to increase their daily value. At 200 milligrams for a single tablet, people don't want to take a lot of tablets, and they don't want to take large tablets. Many times an oxide will be used because of its high potency. But what's actually happening there is there's confusion over just how available that will be, just how bioaccessible that will be, because it's not clear how much is chelated, how much is not. You compare this to the supplement fact panel in B, zinc in this example is 50 milligrams coming from a zinc gluconate source. It says 385 milligrams of chelated zinc gluconate, and that is exactly what you would expect from a stoichiometry point of view. Zinc gluconate has about 14% by weight zinc, and so that adds up to 50 milligrams. This looks like a label that I would believe has a high degree of transparency around its chelation, which is good. We look at the supplement fact panel in C, we see a magnesium source again from magnesium oxide and from amino acid chelate. So in this case, I'm not sure whether they've been reacted or blended or what's really happening here. But again, a serving amount of 250 milligrams for 1 tablet has me suspecting that most of this is magnesium oxide. And we all do fall into this category of let's go for the pack that has the highest daily value on the back, right? Because that's where we think we're going to get the most. But what's really happening here is there's just a lot of confusion. It's not clear whether all of these would be effective. It's not clear exactly what you're buying in some of these cases. Potency of those zinc oxides and magnesium oxides and simple mineral oxides does not necessarily equal quality. So as we move into this and I start to show you the data around solubility and dissolution, come back to think about whether you really need a daily value of 400% on the back of your supplement bottle. Right? We're all sort of victims of doing that once or twice and buying the stuff that says 200, 300, 400%. So what we did first here in our studies was we wanted to verify chelation. As I said earlier, chelation is critical for having the kind of effective absorption in that zinc study as well as that human study. The first test method that's used within the industry mainly is Fourier transform infrared spectroscopy. This is a tool that's used to give lot-to-lot uniformity. It's a fairly standard tool. But we find that it's inconclusive to prove chelation. If the product is truly chelated, as we're talking about zinc bisglycinate here today, you would expect to see a zinc oxygen bond and a zinc nitrogen bond. For those not aware, Fourier transform infrared shows bond stretching. So an additional peak would be necessary on the pattern. The problem is that those peaks would occur in what we consider the fingerprint region of the data. And that's all the way to the right-hand side of the chart where that large peak is that's got several other overlapping peaks. So it's a bit of a forest of a region, and it's not always easy to tell whether that other peak has formed, and certainly sometimes you can't see it at all. So while FTIR is good for giving a lot-to-lot uniformity, it lacks when it comes to trying to prove chelation. So we've taken our testing a bit further here at Innophos. We've added in X-ray diffraction and TGA. To describe X-ray diffraction, that is a test that can actually tell the 3D structure of the compound. So at the end of the test, you actually get an electron density map. You can tell where the individual atoms are. You can tell the bonds, which atoms are bound to others, and the bond angles in between. And so you can draw out an entire structure. The material needs to be crystalline for this to occur, but the data you see in the middle there is the data for zinc bisglycinate. It is crystalline. And so we have this pattern that says without a doubt that the zinc is bound to those two glycines in those positions of the oxygen and the nitrogen. This is great. It's a huge step forward from trying to look for a peak that's buried within the FTIR. So why did we run the TGA? Well, we run the TGA because we want to prove the percent of purity as well. In this case, using glycine as our example, glycine has a different decomposition temperature when it's bound versus when it's unbound. So it's very easy to run the TGA, get the decomposition profile, and know how much of the glycine is bound, how much is unbound. From the TGA, the XRD, and the FTIR, we create a full picture of chelation and have the most transparency and the highest level of confidence possible around our chelation. Next, we'll discuss bioaccessibility and the advantage that chelation provides into this space. And as I move in here to bioaccessibility and bioavailability, it's important to note that this is really the value proposition for a chelated mineral. We want to be able to prove that the chelated mineral has an advantage in the digestive tract. So it's important to understand these terms and to understand this is where this industry needs to go, is to prove that the chelation is actually more effective in the body. So bioaccessibility. The quantity, it's just the quantity of the compound that is available for absorption. So it's the amount of that mineral that is actually soluble through the GI tract. Simple as it gets, right? Bioavailability is the fraction of that compound that actually gets absorbed. So bioavailability is influenced by the food a person has eaten, how bioaccessible the compound is, that person's individual metabolism, whether they may have deficiencies in their body. There's a lot of other factors that fall into bioavailability, and that's why we have to do large clinical trials in order to be able to really understand what's happening here. We can't just try one person, right? But on bioaccessibility, it's something we can do in a laboratory, and it's something that we can prove at a benchtop and in an in vitro setting. So we're focusing on bioaccessibility today. The link between solubility and bioaccessibility. As I said, solubility throughout the GI tract is really what bioaccessibility is. So we started by looking at the zinc bisglycinate, not only in water, but in gastrointestinal conditions. We used a 0.1 normal HCl solution for the gastric environment, 6.8 phosphate buffer, pH phosphate buffer for the intestinal conditions. And if you compare the zinc bisglycinate in both the gastric and the intestinal, you see stability. That's that stability of the compound coming through again. 4.7, 4.6. The percent solubility really doesn't change when it comes to the zinc bisglycinate. However, when we compare this to zinc oxide, we see a bit of solubility in the gastric condition. That's to be expected. The lower pH condition tends to help to dissolve oxides and simple salts. What that's done is now made that zinc freely available for reaction. It's a dissociated zinc +2 ion floating around in the stomach. And as it moves into the phosphate buffer and the pH 6.8 buffer in the intestine, it reacts with other materials. The pH of 6.8 starts to form zinc hydroxide, you get insoluble zinc compounds forming. And because those zinc compounds are insoluble, the zinc then becomes not available for absorption. If I show this to you in a slightly different way, it's the same data, but I've overlaid it on a pictogram here to show the GI tract. The zinc bisglycinate in both the stomach and the intestine has a consistent solubility regardless of the pH that it sees. And because of that consistent solubility, it's remained intact, it's remained stable, and it remains bioaccessible at the most important part of the GI tract, which is the intestine. Zinc is absorbed in the intestine. That's when it needs to be soluble. If we consider the same thing with zinc oxide, you can see once we've hit that intestinal pH, the solubility has dropped significantly, and now it's no longer available for absorption. We're just not bioaccessible at that point because most of it has plated out as a precipitate. This is really the story that we're starting to unfold here from bioaccessibility when we're comparing the chelate to a non-chelate. Okay, so up until now, we've only discussed the two materials as powders. We've tested their properties as powders, but many people take a simple tablet for their supplements. So we moved into investigating the effects of a tablet on the dosage and the dissolution rate. We wanted to simulate commercial tablets. So we made a zinc bisglycinate and a zinc oxide commercial tablet with the same level of zinc. So we adjusted the zinc source level so that we would know that the two tablets have the exact same amount of zinc, so they're comparable. We used ATAB-MD as a co-processed excipient. It allows us to make a fairly simplified tablet formulation without having to have a number of other ingredients. That's our excipient here. We did adjust the ATAB-MD in order to make up for the difference on the differences of the zinc source to get to the masses of the tablets and have them be equivalent. Magnesium stearate was used as a lubricant. That's just to make sure that the tablets come off the tablet press cleanly. Cross-carbamylose sodium is used as a disintegrant. So with these tablets ready to go, we wanted to run them in the dissolution tester, and you can see a picture of that on the right-hand side of the screen. Excuse me. Tablet characteristics. So we wanted to make sure and test them before we started to do any kind of dissolution comparison. So tablet forces were used as 20 kilonewtons. The disintegration time, friability, hardness, and average mass were all fairly equivalent. The one point that might look a little different is the disintegration. We believe the longer disintegration time on zinc oxide had to do with having a bit more excipient in the tablet just to make up for the difference in the zinc concentration. We ran the dissolution test out for 30 minutes, and so we ran beyond this point of the 4.5 to 6.5 minutes. And you'll see in the data here on the next slide that it really didn't show to be an issue. So the tablets are equivalent and we're able to compare them for dissolution. In this case, we did again use the 6.8 pH buffer solution, so trying to simulate an intestinal condition. If you look at this was done on a USP 724 methodology, for those familiar, and we used an ICP to test the zinc concentration of the solution every 3 minutes through the study. Zinc oxide is shown in the dark circles at the bottom. What you can clearly see here is it's basically flat throughout the experiment. It goes from about 5% of the zinc in the tablets being soluble to up to about 10%. So a small increase, but very little improvement in terms of overall solubility throughout the length of the test. And remember, the tablet disintegrated at about 6.5 minutes. So this is not an effect of tablet hardness. This is well beyond. Comparing to the zinc glycinate, we can see an immediate improvement at about 10% on the first data point, a strong increase up to about 25% in less than 10 minutes, and then a continual growth up to about 35% at the end of the 30-minute mark. And So at the end of this 30-minute experiment, we have a 3-fold increase in solubility of zinc bisglycinate as compared to zinc oxide in conditions that simulate the small intestine. Remember, this is the point at which you really want the zinc to be soluble, to be available for absorption. And so this is 3 times more available for absorption at that point than the zinc oxide. Lastly, I'd like to conclude with some of the uses and benefits of chelated minerals. Getting back to the powder now, comparing some of the data that you'd want to see from a formulation point of view. You can see the zinc bisglycinate slightly greater in both bulk and tap density. Both products are similar on particle size and not too dissimilar in terms of pH. The solubility is the real key here. We've got much greater solubility in the zinc bisglycinate versus the zinc oxide. Formulators are constantly challenged these days to add supplements to an expanding list of dosage forms. I put a few of them on the bottom of the screen so you can see them. But if you wanted to try to add zinc oxide into any of these clear applications, so the soft gels or the gummies or the liquids, you would not be able to add it directly. It's just insoluble. You'd have to add an acidulant to help dissolve it. So by switching to a zinc bisglycinate, you've got a product that can go directly into a soft gel or a gummy. Because of its solubility, it already has an advantage. Whichever form you use for your product, recognize the benefits of chelation are significant for both the manufacturer and the end consumer. We've shown that performance and usability occur without compromising the form. We've talked about having confidence in chelation with additional testing that we provided from an analytical standpoint. And the stability and solubility of the chelated mineral give that improvement on the bioaccessibility time, as well as the enhancement in dissolution, 3 times the rate of dissolution. For consumers, transparency of this chelation, as well as the bioaccessibility of the supplement are true benefits that they would value. At Innophos, we have our product line of Chelomax minerals. If you recall back to the marketing data on the 2nd or 3rd slide there, you saw calcium, magnesium, and zinc are the major minerals that are leading the way right now. So it shouldn't surprise you that you see those on the list here. But these are all products that we have that are have the same level of transparency and verification for chelation as I described here today. We use our same 3-step verification process to prove full chelation. We start with X-ray diffraction to confirm the structure, TGA to confirm the purity, and FTIR, again, as a lot-to-lot comparison to show the product remains consistent batch to batch. This is our 3-step testing methodology, and we believe it's unmatched in the industry. So to summarize, we described the chelation, and we talked about some of the literature data that is available that proves efficacy of chelated minerals over inorganic minerals. We discussed our improved analytical methods because of this need for transparency in the market. And we shared solubility data showing chelated minerals are improved versus inorganic minerals throughout the GI tract using simulated solutions. We followed that up with chelated mineral dissolution data to show that 3 times the rate of improvement over the inorganic minerals. So as you can see, the key messages, chelated minerals are superior to the inorganic. Bioaccessibility is key to mineral absorption, and chelation can enhance the dissolution of the metal. Thank you for your attention today, and I'll open the floor to questions now.
All right, thank you so much, Bob. And again, I'll just encourage our audience to post your questions if you like in the chat, and I'll share those with Bob directly. I also wanted to note that I don't think I didn't share this with the whole audience before, but we did get survey results, and I'll just share those, and partly for your benefit as well, Bob. When we asked if people believe they have a good understanding of chelation, 44% of people said yes. So, excuse me, that's less than 50%. So I think it's remains a point of confusion a little bit, even for those well-versed in the industry. We also asked if you seek out chelated minerals for the supplements that you take, and 67% of people said yes. So there's some understanding that it's a good idea, but maybe not a complete understanding of why. We also asked about whether you look at the source of minerals used in your supplements, and 89% said yes. So that's pretty interesting. I mean, there could be a variety of reasons why, and those are things to explore, of course, perhaps with customers, and those affect how we address particular dietary considerations. Some people are making sure that something is maybe not coming from an animal source. There's a variety of reasons again, but I think that's pretty interesting that 89% said yes, they're looking at the sources. So I have a number of questions, Bob, so I'm gonna just dig right in here. I guess first off, just very sort of, well, and then before I dig in also, I just want to tell our audience too, if they do go to the white paper that's supporting the information that you were presenting today, again, that's available through the link that's on the page here. All of the studies that you were talking about are cited on that white paper also. So sometimes people like to go directly to the studies that are discussed. So I just want to make people aware that that's available. So just back into questions here. Okay. So why choose zinc glycinate in particular? Why glycinate?
Yeah, so glycine is a nice ligand to be using for chelated studies because it does offer the highest level of potency while still offering chelation. As we move through other amino acids, you increase the molecular weight of the amino acid, and that in turn lowers the total percentage or potency of the mineral. So it's a good place to start because you've kept the potency as high as you can, but you're also chelated.
Is that because of just the molecular structure?
Yeah, it's the molecular weight of the glycine. This is why zinc glycinate is about 28% zinc, while zinc oxide is about 80% zinc. So you do lose potency while adding the chelate there, but what you gain is efficacy. Right.
I'm going to dig back into that in a moment, actually. And the glycine, is that something that's synthesized, or does that come from a particular source?
Yeah, I mean, we use several sources for it. We do. It is a manufactured source. Yeah.
All right. You also mentioned when you were talking about the shrimp study earlier, you talked about immune parameters that you measured or that were measured within that study. Can you elaborate what that means? What are the immune parameters that are measured?
Yeah. You just let me, I have those notes on my slide here. If you don't mind, I'll go back.
Yeah, we don't mind at all.
I'm not an expert when it comes to shrimp. That's
yeah, shrimp. Yeah, and again, for the audience, a version of the slides in PDF form is available too, if you'd like to look at those.
Yeah, so it was serum superoxide dismutase and phenyloxidase activity were both tested. So those are enzymes associated with immunity. They were both tested, and the data is available in the paper if that person who sent in the question wants to see it. And this was also, like you said, referenced in the white paper. So the reference is on there as well if they wanted to get that article and dig into that immunity data.
So is superoxide dismutase also a marker in immune health for humans then?
I believe so. Yeah.
Yeah. Actually, something just popped in from the audience right now, so I'm just going to ask it. Again, I have kind of a running list of questions here, but this is someone that's managing OTC products in gummy form. some of the projects include zinc, some with zinc sulfate monohydrate and some with zinc citrate. Can you compare bisglycinate and zinc sulfate and monohydrate in supplements for gummy application? Again, pretty popular application format right now. So what are the effects then of zinc sources, especially in that kind of format?
Yeah, so zinc sulfate is again, an inorganic source, an inorganic mineral source, whereas zinc citrate might be bound as, what was the last one? The glycinate?
It was monohydrate. I said compare zinc bisglycinate with monohydrate and zinc sulfate. Sulfate monohydrate. Sorry.
Yeah, it's really, it comes down to usability. If you have a material that you can't formulate with because it won't stay in solution, or it might react with something else that's in that space, it just creates headaches for the formulator. So if you're in a gummy application, and obviously I don't know the full formulation of what's being worked with here, but you've got to worry about not only the solubility of the individual ingredients, but also whether they will react, in the gummy or on the shelf over time. So it really depends on the full formulation of what makes the most sense.
I guess I think you already answered this, but I'll just maybe drive this point home about, well, the question is, why aren't all your minerals chelated? So maybe you could just qualify that a little more.
Yeah, so we try to offer products that serve the entire industry. We are moving, trying to move as much as we can to the fully chelated. It's a process for us to qualify internally a product as Chelamax, but we recognize there is some customers out there who are not ready for that and want to work with their formulations as they are. So we want to make sure that we offer those as well. So we offer a full range to try to serve the industry. Right.
There's all different kinds of products and price points. And I know you're not going to talk about pricing here, and that's a sales conversation, but maybe in a very generalized way, maybe that's just something you can just speak to. I guess I would imagine that we're talking higher price point, milligram per milligram, but maybe not necessarily per efficacious dose. Any comment?
Well, yeah, I'm not going to talk directly about pricing, that's for sure. But I will say that our Chelamax product line is a premium product line. We are providing additional data beyond what others in the industry might provide from a chelation point of view, and we are investing in the science to show bioaccessibility and beyond. So it is considered a premium product.
Well, and because the bioavailability, first the bioaccessibility, and then, of course, more relevantly here, the bioavailability is higher.
Well, hold on. I have not proven bioavailability. We didn't discuss bioavailability. We only talked about bioaccessibility, and it's important to make sure you have a distinction there.
All right. Yeah. Well, with that distinction, with bioaccessibility improvement, we'll speak specifically about zinc bisglycinate, which is what we addressed today. Does the form allow perhaps formulators to use a lower dosage per serving for efficacious dose, and then maybe affect even the size of the tablet that consumers would ingest?
Yeah, it's certainly a possibility. Obviously, we're seeing, from a bioaccessibility point of view, we're 3 times more accessible than the zinc oxide. So it's common sense to say you could use 1/3 as much and have the same kind of bioaccessibility. But keep in mind that you want to ultimately have, like you said, an efficacious dose.
I mean, does that affect any GI experience for the consumer too? I think sometimes people get some GI irritation from high dosing with zinc in general. So has there been any any clinicals looking at that
Yeah.
that experience?
I've looked into it. I don't know of any clinicals that have looked at the GI distress for zinc. If somebody has one and wants to kind of send it to me in the chat, I'd love to see it, because we did look at it as part of this protocol, but because we couldn't find a methodology that we thought was appropriate, we just left it out at this point. It's very subjective to the individual.
Yeah. Understood. I mean, so, producing a premium product for a brand is one thing. Communicating the benefits to the consumer is something else. How does Innophos help support the brands and their education efforts for their customers, for consumers? Again, it's just translating the information to the consumer is always a challenge.
Yeah, and we've started on this pathway, right? The part of presentations like this are part of the road that we're building in order to educate. We work closely with our sales and marketing team, the technology team does, so that we can visit customers, inform customers, and ultimately provide the necessary information so that our customers can inform their customers. So we believe it to be a path, a road that we're traveling, and we want to lead in science when it comes to these chelated minerals, but education is a big part of it.
Yeah, and I think that consumers today are interested in more transparent access to information about the products that they're consuming. And, when there is clinical evidence and support of information available, in my opinion, this is just my humble opinion, I think it behooves brands to provide some tools for access to that information directly to their customers as well, to consumers. It only elevates their ability to make smart purchasing decisions, and also actually elevates the entire proposition that the dietary supplement industry has to offer. So, I think having that science first approach really can only benefit not only from the front end, but, from the back end, of course, also for any supplement purchasing choices. So just a little bit more just about delivery format before we head into our closing here. Does zinc bisglycinate always need to be tableted? I mean, I think we touched upon this a little bit, but can that efficacious dose be delivered in any other types of formats, even like powder forms, like, beverage mixes, anything like that? Or, because pill size is always a factor. So what are some of the options?
Yeah, it is wide open. Zinc's kind of nice in that, a daily value, or the RDA for zinc, is about 11 milligrams. So you don't have to go beyond a single tablet, even with a chelated mineral, to get the full 100% of your daily zinc. But you don't need to be in a tablet form. We chose the tablet form because we were interested in the dissolution data, and we didn't feel as if the powder form or something like that would be, equivalent for a dissolution study. So we made the tablets because we could, and we thought it would be an interesting data point to have. But you could certainly have the zinc glycinate in a powdered form, no question. We have some, if I go back, we have a few that are actually directly compressible as well. You can see in the bottom corner the little stars. So the calcium bisglycinate, mag citrate, and mag bis are all directly compressible, and two of those are granular. So they're all powders. It's just how you'd want to work with them.
And what if they were included in a gummy? So then it was going through some oral digestion.
Yep, it's perfectly fine. Obviously the zinc bisglycinate has a nice solubility. Solubilities do range with these products. They're not all, the exact same as the zinc bisglycinate, but they certainly work in a gummy formulation.
All right. Well, thanks for answering all of those questions, so many of them. And some of those questions are in the chat also. So, if you choose to go back in, Dr. Finn, you can see who asked those questions as well, too, if you want to make those connections. I'm going to bring us to a close because we're just about at the top of the hour. So I want to thank you, Bob, for spending this time with us today. That was so informative, and clearly you are the expert in the field here. And I also, of course, want to thank Innophos for making the entire program possible.